So welcome to our first set of notes in chemistry, and this is measurements and observations in Unit 1. And so let's first just kind of define what chemistry is overall. Now, chemistry is the study of nature and all of the materials in the universe and the changes they undergo. Now, like all true sciences, studying chemistry requires carefully paying attention to the things that happen. And the things that happen are what we call observations. So let's start off with what is an observation? Now, an observation is overall the important information that's collected from paying attention to or watching something. And so here the key is the fact that you're actually paying attention to what you're seeing. And so with that, let's just kind of take a second and let's watch the demonstration of food coloring being added to different liquids. Now, when we say the liquids, we're just going to use hot water and cold water. And while you're doing that, I want you guys to try and record any observations that you make, meaning just about anything at all that you notice about the video. All right, here it is.
Guys, today we are going to do an experiment, and you're going to observe what is going to happen in the experiment, and that is what you're going to write down in your observation chart. We are taking cold water and some hot water. You can see the smoke coming out of the hot water, and we are going to take food coloring. One is blue food coloring and one is green food coloring. We're going to put a drop of blue food coloring in the cold water. And we're going to put a green food coloring in the hot water. So now look at this and record your observations. Check out what you see is happening in these kinds of water, how the food coloring looks like. What do you see? What do you think is happening? So make the observations, write down, and then we'll discuss about it.
So now that you've had a chance to write down some of your own observations from the video, let's just kind of briefly go over some of the observations that people usually make. And so the first, the food coloring spread out in the water in each of the beakers, great. The food coloring is green. The temperature of the hot water is 80 degrees Celsius or whatever it might be. The temperature of the cold water is 4 degrees Celsius, again, whatever it might actually be. Otherwise, the food coloring spread out more quickly in the hot water than the cold water. That's great. These are all good observations. Now, the key here with observations is the fact that all of these observations need to be things that everyone can agree upon, at least to a certain degree. Meaning it's okay if your lab partner disagrees with you about a measurement and they say that the length of the piece of paper is 12.25 centimeters. However, you say it's 12.22 centimeters. Not a big deal. You guys generally agree on that observation. Now, with these observations, one of the big things that we like to do in science is we can sometimes make conclusions, or sometimes what we call inferences, using the observations as evidence. And so the key here is the fact that we can't just make a statement. We have to actually base it off of what we saw as an observation. That's one of the big keys in science, is that you need to be able to back up what you're saying using your observations or using evidence. And so with this, an inference overall is drawn from evidence and reasoning, meaning you can't make an observation like the sky is blue and then all of a sudden decide that because the sky is blue, the grass is green. That doesn't work. And so you need these things to tie together in some way. And so with that, it means that it involves the observations as well as some previous knowledge. So you could say the sky is blue, and because the sky is blue, the sun can activate photosynthesis in the grass, which is why it's green. And so there's an important difference in there. You need to be able to connect your ideas with evidence and some kind of thought process. Based on the observations, what inferences do you make from this demonstration? All right, so some of the inferences that people might have included would be the molecules of the water in the hot water are moving around more rapidly than in the cold water. And that's what causes the food coloring to spread out more quickly. Okay, another inference that we could make would be the molecules of water in the hot water are more spread out, which allows the food coloring to move faster through the water since there's more space. The molecules in the cold water are more tightly packed together, and therefore it's harder for the food coloring to get through. Okay, so we have two separate observations here, or two separate observations and inferences that are made to explain why the food coloring moves faster through the hot water than it does in the cold water. Now, in reality, with these two inferences, one of them actually ends up being correct while the other one isn't. So take a second based on your level of knowledge and think about why you might think it's true. Hopefully, only this inference ends up being true, and hopefully you picked it. It is the first one. The molecules of water in the hot water are moving around more rapidly than in the cold water. That's what causes the water food coloring to spread out more quickly. Which is a true statement if you kind of picture a beaker here and our little water molecules, and we're just going to draw them as circles. If we picture our water molecules, when the water is really, really hot, these things are moving around and bouncing a lot faster. So if it helps, picture something like boiling water. So when you boil water, the idea is the water molecules slowly move faster and faster and faster until eventually they have enough energy to break away and become a gas. And so with this idea, the other one also uses observations and some knowledge of the water being made up of molecules and reasoning. So technically, both of them are good inferences, but only the first one stands up to other types of testing. And so that's the important part about what makes that first inference that we made a true statement. The second one, on the other hand, although it's a good example of an inference, it just doesn't stand up to science. So now that we've talked about this, let's talk about inferences with a little bit more detail. And so the important thing about inferences is that they don't need to turn out to be true in order to be a good inference, just like we saw with our last example. It just has to use all of the available evidence and some solid reasoning to explain the observations. Now, fun fact about this kind of whole thing, this idea right here is known as philosophy. So, in general, philosophy is basically just the idea of trying to convince people that you are correct in some way using logic, reasoning, and inferences. So, with that in mind, when you guys go take a philosophy class in college, um, that's the basic premise. You just got to convince people that you're correct because you have solid reasoning. Anyways, let's kind of move on from this idea of inferences and let's talk about some observations. So, with observations, we have different types, and I'm sure a bunch of you guys already know this. We can divide these two types of observations into quantitative and qualitative observations. Now, with this, a quantitative observation is one that involves a number. That's the key here. It has to involve a number. So, quantitative, think quantity, meaning number. So, an example, the gummy bear has a volume of 1.8 cubic centimeters. Now, with that, a qualitative observation, on the other hand, a qualitative observation does not involve a number. So, one example would be the gummy bear is green. And so that's the big difference here is that quantitative means quantity, meaning a numerical value. Qualitative means it does not involve a number in any way. So a lot of times when you think about like observations, for example, observations can be defined as either quantitative or qualitative. So quantitative would be something that you measure, and qualitative would be something that you see. So we could say the see and describe. for example, let's just kind of put it into, similar to like a lab process. If we're talking about quantitative observations of, let's just say, making cookies, quantitative would be the number of cookies you make. Qualitative, on the other hand, would be something like the color of the cookies at the end of baking. So that's the big difference here. And so let's just kind of write a quantitative observation from our food coloring demonstration. So here's a closer look. All right, now let's write a qualitative observation from our food coloring demonstration. And let's just kind of take a look at that again so you guys have a chance to look at it. All right, so now that you guys have had a chance to make some of your own observations, let's actually look at just some generic quantitative and qualitative observations. So some quantitative observations from our demonstration that students often volunteer might be the volume of the water was 350 milliliters, or whatever it might be, or whatever you might believe it is. The temperature of the water in the hot beaker is 80 degrees Celsius. Again, it's got a numerical value in it. And then with some qualitative observations, remember these describe qualities. This would be the food coloring is blue, or whatever color it ends up being, or the food coloring spreads out faster in the hot water. So notice both of those are qualitative observations. Now, based on these observations that we make, a big important thing, especially about quantitative observations, is this idea of measurements. Now, when it comes to measurements, some of our quantitative observations have to be measurements, meaning these involve some kind of measurement tools. For instance, a ruler, tape measure are two things that can be used to measure the length of an object. Now, rulers and tape measures are both tools that we use to measure things. So just kind of take a second, think about what other tools for measurement you might have in your house. All right, so some of the things that I thought about were a thermometer. Um, let's see, other things that I have would be a voltmeter in my house, which measures electricity. Then, aside from those two things, other things could be like a protractor that you guys would use in math class, or some other kind of out of the box, we'll call it things, would be like the water meter in your house. And yes, every house or every townhouse has one. And if you're in an apartment building, apartment buildings have them too. Aside from that, there are also things like clocks. And of course, the last big one that you definitely have in your house is a scale. But all right, that's it for today's video, and I will see you guys later. Have a good one.